So good morning to everybody and welcome all to the SCAI training session on heat pump systems. My name is Antonella Uras. I'm an engineer and my role involves oversight of quality assurance for a number of SCAI programs. This session is part of a series of webinars on energy upgrades for contractors registered on the Better Energy Homes program. This training will be delivered by two experienced SCAI inspectors, Michael, who is also a surveyor and a BR assessor, and Matt, our expert in heating design and installation. The session will cover important aspects of heat pump system design, installation, and commissioning, and will give you important tips on how to improve quality and ensure compliance with the grant requirements for Better Energy Homes. Please feel free during the presentation to type your queries in the chat, and we will try to address as many as we can in the Q&A session at the end. So I'll now hand over to Michael to start the presentation.
Okay, thank you, Antonella. So I'm going to start and talk a little bit about our agenda for today's presentation, starting with the presentation introduction. Moving on to the aim of the Climate Action Plan. We'll touch on the technical assessment overview and the grant process documentation and specifications. We'll also talk about the system design, including the sizing, assessment, and declaration of works. And then on to the quality monitoring and inspections. And at the end, we'll just finish with a conclusion and question and answer session. So starting with the presentation introduction. So the aim of the presentation is to assist you with the design, sizing, and installation of the heat pump systems for the Better Energy Homes grant, and includes additional guidance on useful insight into the Better Energy Homes heat pump grant process, ensuring compliance with standards, specifications, and regulations, heat pump design, sizing, and critical documentation requirements, and then quality monitoring and inspections, and we look at some common reworks. Now we'll start and we'll talk about the Climate Action Plan, and what it's really about is moving towards a low carbon energy society which is sustainable, secure, and clean energy. What we really need to do is use less energy and clean energy, and this is where the heat pump technology comes in, where we're trying to develop new solutions to meet our energy needs, leading to a transition into smarter and more sustainable energy activities. So about the Climate Action Plan, as you know, it was published in 2019, and it recognises that Ireland must significantly step up its commitments to tackle climate disruption. It sets out an ambitious course of action promoting the widespread adoption of heat pumps, and it sets ambitious retrofitting targets for 2030, which include 500,000 homes to be brought to a BE or B2 or cost optimal level, and 600,000 heat pumps, of which 400,000 are to be retrofitted. This presents a huge opportunity for small and medium-sized businesses, and with our homes using 7% more energy than the EU average, this needs to be addressed, and this is how the Better Energy Home scheme can play its part. And with homeowners becoming more climate aware, contractors could enhance their business reputation and get more business. So how does the Better Energy Home scheme play a role? Well, it helps meet higher energy performance standards by increasing retrofit activity. It promotes low carbon solutions such as heat pumps in residential buildings. Renewable heat source such as a heat pump reduces CO2 emissions. And this improves our living standards by making our buildings more comfortable, healthier, and less costly to heat, which is the aim for the homeowner. So here we have a breakdown of heat pump applications per county. And as we can see, some of the counties have a lower heat pump applications, and this could be potentially present as a business opportunity for yourselves. As you can see, potentially how many homes are heat pump ready in your region. And we will be providing additional statistics broken down county by county on potential heat pump ready homes towards the end of the presentation, which you can take a look at later in more detail as we'll be circulating this presentation to you. So on to houses completed to date. Firstly showing the percentage of heat pump costs here on this graph. Moving on to the types of heat pumps completed, as you can see, the air-to-water heat pump is the most commonly installed under the grant scheme. And the last chart here is the breakdown of the dwelling years of construction, with an average year of construction of 1973. Now that brings us to the technical assessment overview. So as part of the application process for the Better Energy Home Heat Pump System grants, a technical assessment is completed to advise the homeowner on the energy performance of the dwelling. Now, the technical assessor's role is different to that of the heat pump or contractor, where the technical advisor will look at the thermal performance and fabric and ventilation in a technical assessment, and then will determine the heat loss indicator and detail any upgrades needed to reduce the heat loss to required level. Whereas the role of the heat pump contractor is more focused on the design, including the sizing, installation and commissioning. Now, the contractor should be make themselves aware that there are further grants available for fabric upgrades, which we'll look at shortly. Now, during the grant application process, the contractor will issue the quote and then design the system. Moving on to then the homeowner can apply for the grant and the contractor can help with this. And when the works are complete, the contractor can do his quality assurance and sign the relevant documents. Then the homeowner would submit the request for payment along with their documents to get paid. And then a sample of inspections will be completed as well. So the role of the technical advisor. Well, the technical assessment is mandatory for the heat pump system grant application and is completed by a BE or assessor with appropriate qualification. The assessor provides independent guidance in a technical assessment. The dwelling heat loss indicator is then determined, and then will detail any upgrade options if required to reduce the heat loss to the required level. And finally, the assessment will focus on the energy performance of the building fabric. Now, we have a graphic here outlining the role of the technical advisor. Firstly, they will look at the fabric and ventilation performance of the dwelling to achieve that heat loss indicator I was talking about. And then the technical advisor will provide the heat pump general advice along with any other energy saving measures that they may deem appropriate. So the heat loss indicator. Now, domestic heat pump systems are more efficient when they operate with a dwelling with low fabric and ventilation losses. So this enables them to operate at lower space distribution temperatures and to meet the space and hot water demand. Now, the metric used to determine the dwelling has sufficiently low fabric and ventilation heat loss is the heat loss indicator. Heat pump systems will only be eligible for the Better Energy Homes grant when installed in dwellings meeting the following conditions. So where the HLI is greater or less than or equal to 2 and less than or equal to 2.3 under certain conditions, which I'm going to outline here on the next slide. So the conditions would be the maximum exposed U value of the wall at 0.37, the maximum roof U value of 0.16 and 0.25 where not accessible, the maximum window U value of 2.8, and the maximum adjusted infiltration rate of 0.5 air changes per hour. So really where the HLI is between 2 and 2.3, in some cases it may not be economically feasible to upgrade the home further, and the homeowner should be advised that the cost savings may not be significant depending on the fuel and efficiency of the current heating system. So there are grants available. So if the HLI is greater than 2, then the homeowner will be advised to upgrade the fabric of the building to qualify for the grant. And as you can see, the SEAI grants available as outlined here. And as you can see, there are different insulation grants as well as heating and hot water grants. And we look at the heat pump systems grant here ranging from 600 to 3,500 euros, in addition to the technical assessment grant of 200 euros. And again, contractors should make the homeowners aware of these grants available. Additional grants are available from the Better Energy Home Scheme, which includes solar PV and battery storage grant. And also you can see the electric vehicles domestic charge point grant there of 600 euros. That brings us to the grant process documentation. And we have some key points here in relation to this, with the Deep Heat Pump Designer installer form, including the Deep Heat Design tab and ECODESIGN datasheet, has to be sent in with the declaration of works. And these are the handover documents to be provided to the homeowner, and these should be available for inspection. Now, these are the type of documents we're looking for. Now, there's quite a lot of documents here, but they all have their own importance. Some would be for best practice for business and customer service. Some would be for required to comply with the regulations, for example, the F-gas, the Safe Electric, or the RECI cert. And SEAI have governance rules around the spend of public money, so we absolutely need contractors to provide the necessary documentation to the homeowners, including the documents highlighted here to be sent in with the declaration of works. And it's important to note as well that long delays and also the claim payments due to the missing documentation, so this is a critical point for the grant. And also the heat pump installer must also provide the required data and information for the BER assessor carrying out the post-works BER assessment. And if required, the heat pump system design data must be provided for early assessment before the works are carried out. Now, the declaration of works, and this should be completed after the works are finished and left with the homeowner, and should be completed by the homeowners, contractors and BER assessors to claim for the grant. All sections should be filled, and particular attention is required to the following items, including the date of the works, the details of the heat pump, the total costs, and any comments relevant to the application. Now, further guidance is available in section 5.2 of our Contractors Code of Practice, and as you can see, it's available there on the website at that link. Now, on to the sign off on works, including contractor ID, company name, and date. Note as well, the contractors need to be fully aware that they are signing off on compliance of their design, installation and commissioning. And by signing the declaration of works, they are taking full responsibilities under the QADP. Now on to the BER declaration of works section, and it's to be completed by the BER assessor. The calculation is based on the ECODESIGN and installation details. Efficiencies are calculated with the deep heat pump methodology. And just to note as well that these values must meet the minimum heat pump efficiency requirements as seen there. Now, the designer installer form, just to let you know that there's a new version of this form, which if I could just encourage you to download and use the current version. 2 copies must be supplied to the homeowner. And you can see there instructions on how to fill out are included there in the BER and heat pump grant checklist, as you can see there on the bottom. Now on to the heating design tab, and we can see this version here where it calculates the total heat loss and output, but we're just going to go through this in more detail further on. Now the ECODESIGN data sheet, again 2 copies have to be provided to the homeowner, and you have to ensure that this is available for products you choose to install. You may have to ask the manufacturer at design stage, and it is the legal obligation for the manufacturers and suppliers to provide this to you. Now, the ECODESIGN data sheet, and here we have the ECODESIGN and energy labelling regulations, and these must contain the relevant regulations outlined here and the details of the manufacturer. On to the commissioning and maintenance, and every unit must be commissioned by a trained and approved engineer. The commissioning form must be filled out and left with the homeowner. And the annual service and maintenance contract has to be put in place as specified by the manufacturer's guarantee, and the homeowner must be made aware of this requirement. Now the contractor registration. So really you want to be completing the contractor registration form and read the terms and conditions. Study the code of practice, specifically the heat pump section and the quality assurance processes. And there are minimum qualifications required, as the plumber qualifications required, the manufacturer training certificate, and completion of the specific heat pump course. And just to note that this course was temporarily waived pending on availability of courses, but is now required, so the contractors who have not completed the course should do so. Just a note on heat pump courses as well, some training centres offer a curriculum that covers very well the design and sizing in addition to the installation and commissioning. For example, I think DKIT offers and METAC. There may be other providers, but we would encourage you to check with the training provider before signing up. And just all contractors must be competent in the design, installation and commissioning of heat pump systems. Now, that brings me to the technical standards and specifications. Now, so what heat pump units qualify? So firstly, to qualify, the heat pump units must be compliant with the ECODESIGN and must have been tested to the correct standards, CE marked and satisfy the minimum deep efficiencies as outlined here. Now I'll move on and chat a little bit about the full standards and specifications for the scheme. Now this quality of service delivery is central to the reputation and effectiveness of all the home energy efficient works supported by SEAI. And you can see that the supports and guidance documents are available on the website. They include the Domestic Technical Standards and Specifications, Heat Pump Section 6.9, the Better Energy Homes Contractors Code of Practice Section 5.2, the Quality Assurance and Disciplinary Procedures for Contractors, and the Domestic Heating Design Guide. This is a guide is to assist the contractors in to specify the design of wet central heating systems, and the draft SR 50-1, which is the Code of Practice for Building Services Part 1. And this would be of interest to installers involved in the design, installation and commissioning of domestic plumbing and heating systems. There are also draft SR 50-4, which is the Code of Practice for Building Services, heat pump systems in dwellings. And this is out for public inquiry, which, if you wish, that you can have your say on. There are supports and guiding documents also available, including the Heat Pump Designer and Sign-Off Sheet. There is some additional guidance from the Heat Pump Association of Ireland in the form of installation guidelines, the REWORKS appeal form. And just to note that all registered contractors must ensure and their operators are fully familiar with the QADP, and all work should be carried out to the relevant specifications, best practice and technical guidance documents. Now on to refrigerant gases and F-gas regulations. Now most refrigerants used in heat pumps are hydrofluorocarbons and have high global warming potential. So releasing these gases into the atmosphere must be absolutely avoided, as it undermines the carbon savings achieved by the heat pump. So you need to comply with the F-gas regulations, and if we're working with refrigerant gas, you need to be certified. But more information is available on the EPA website, and we've provided the link here. Now, so this brings me on to the heat pump design, sizing and assessment section, which I'm now going to hand you over to my colleague Matt Mullen to continue with the rest of the presentation. And just a reminder as well that if you can submit your queries or questions there via the chat bubble at the bottom of your screen, and myself and other members of the panel will be there to try to answer your questions for you. Okay, I'll hand you over to Matt there now.
Thanks very much, Michael. So I'd like to take you through the design, sizing and assessment section. So firstly, what do we look at? What is the heat pump system? So for the purpose of the SEAI grant, the heat pump system is made up of three basic elements. It's made up of the hot water system and controls, the heat pump unit, and the heat emitters and their controls. So if we look at the heat pump system design, it's the responsibility of the registered heat pump contractor is to do the following: to do the heat loss calculation on a room by room basis, to size the heat emitters, to size the heat pump, to assess the efficiency of the heat pump for compliance, that's done through DEEP, and other design considerations such as the hot water, the location of the units, and the controls of the system. So just to give you a bit of background, when we talk about heat loss calculations, this is taken from an engineering journal that was written in 1964, so it's over 50 years ago. And the same things have been spoken about that we speak about today. It's how design is essential when we're looking at heating systems, and even more so now we're talking about heat pumps. So how do we go about our heat loss calculations? Firstly, it must be done in accordance with a recognised standard. An example of some of these recognised standards are the CIBSE Domestic Heating Design Guide, SR 50-1, which is the Code of Practice for Plumbing and Heating. SEAI have guidance on it, and I'll go through that later. And finally, as Michael had mentioned, SR 50-4, which is the Code of Practice for Heat Pump Systems in dwellings. That's out for public consultation, and I would encourage everyone here to have their say on it, to download it and make comments on it. So to go through the heat loss calculation, so what do we need to consider? We need to consider the fabric heat losses, such as walls, windows, doors, roofs, floors, etc. And we need to consider air infiltration losses as well too, because a third of the air is lost through air changes, or a third of the heat is lost through air changes. We need to size and design the heat pump properly, so it has to be capable of working in temperatures of -3 degrees outside, so that has to be a consideration when we're doing a design. And finally, the other thing is heat emitters must cover the whole house. So we can't just fit radiators downstairs and hope that the heat goes upstairs. So we need to ensure that that all rooms are heated by radiators, underfloor heating, or by whatever means, unless we can demonstrate through calculations that there's no requirement for heat in the room. The heat pump sizing. So the heat pump itself must be capable of heating 100% of the space heating under design conditions. And secondly, it must be capable of heating 80% of the hot water demand. All heat pump system grants are based on heating and hot water, with the exception of air-to-air, which is based on the space heating only. There are no grants for hot water-only heat pumps, so that's an important point to note. Design flow temperature. Look, I'm sure most of you know this already, but the lower the flow temperature, the higher the efficiency of a heat pump. Correct design is essential for maximum efficiency. So we can see there from the chart, lower temperatures, higher efficiencies. Guidance on size and heat emitters. So I want to talk through SEAI's guidance. So SEAI, have it there. There's a link here, as Michael has mentioned. We passed it around to all the participants, and you'll be able to click on the link, so you don't need to worry about where we have them at the moment. It's broken into sections. It's broken into the heat requirement, an example of heat loss calculations, radiator sizing, important notes on existing radiators, other system design considerations, and documents that have to be provided to contractors for better energy homes for the grants for the heat pump system. Sizing heat emitters. So we need to, when we look at heat emitters, we need to look at what type of heat emitter we have. We need to look at what temperature they operate at. Typically, underfloor heating systems, we're talking about a flow rate of about 35 degrees. Low temperature radiators can vary depending on the size of them, 40 to 55 degrees. And air systems, air-to-air units, we need to look at the heat output, the airflow rate, and we need to look at the temperature as well too. Manufacturers will give you those details generally on them. So typically, if we look at a radiator here, I want to talk about radiators and sizing radiators because the flow temperature is critical to the size of the radiator. So heating systems, different heating systems operate at different temperatures. So what we need to do when we look at a radiator, so that we can determine the output, we need to know what the delta T is. So how do we find the delta T? Well, it's the average of the flow and return temperature less the room temperature. I have a couple of examples here, which if we take a non-condensing boiler. So a non-condensing boiler, we normally, typically flow temperature 75, a return temperature 65, a room temperature of 20 degrees. So if we look at that, we would be looking at a delta T of 50 degrees. That's how we calculate the delta T in that scenario. For a condensing boilers work more efficiently at lower temperatures, specifically when the return temperature is less than the dew point. So they would have been run lower. So the delta T would have been different when we're looking at a radiator for a condensed boiler as it would for a non-condensed boiler. So an example here, 65 flow, 55 return, less 20 degree room temperature, we would have looked at a delta T of 40. Now, in the case of a typical wet heat pump system, as we've seen from the graph earlier, the lower the flow temperature, the higher the efficiency of the unit. So by design, it's natural that we will try and design it with as low as flow temperature as possible. So we can see here that the delta T on this example, 45 flow, 35 degrees return, most likely for a radiator system, less than 20 degrees, would give us a delta T of 20 degrees. Why do we need this? Well, I suppose the flow temperature, as I've mentioned before, it's critical to the size of a radiator. The output of a radiator is going to be governed by the temperature it's heated at. So the rate of exchange depends on the difference in temperature. The chart on the right, so this is how one manufacturer demonstrates their outputs. So on the chart on the right, we can see with a flow temperature of 75 degrees and a return temperature of 65 degrees, that radiator, which is a 400 by 1600. So if we look up this chart, this is a snippet from a radiator manufacturer's chart. This is how they demonstrate it, and it will show that that radiator will deliver 602 watts, which would be typically at a delta T of 50 degrees. Whereas, where we look at it with a flow temperature of 55 and a return temperature of 45, which is a delta T of 30 degrees, we can see it will only deliver 318 watts. So we can see the output is significantly lower when it's run at a lower temperature. So the principle of this is essential when we look at heat pumps. Another way that manufacturers may do it is they may give us the temperature based at a delta T of 50 and give us a conversion factor. So we can see in this one here, we've got the list of 600 by X length, and it gives us the output. And we need to look at a conversion factor if we differ from a 50-degree delta T. So in this example, if it's 20-degree delta T, and we can see whatever that output is, we need to multiply it by a factor of 0.309, which is less than a third of the output. So what happens if there are existing radiators? Well, firstly, it may not be necessary to replace existing radiators. It's most likely that existing radiators were sized for a higher delta T value, for example, the delta T of 50. Verification of this sizing for the grant is required. So it's essential that you verify the size and the output of the radiator and provide that information. So how would you go about doing it? Well, there's the supplement to the domestic heating design guide. There's a heat emitter supplement to it. So that will give us typical radiators or on sale during a period, and it will give us the estimated output of those radiators. So we can match them up visually and by ear and stuff like that. And that will give us an estimate of what the output of that radiator is. Then we need to apply a conversion factor. So I have an example here. We have a 1450 by 500 rad. You can see it there from the image, single panel convector. I checked the heating emitter supplement to the domestic heating design guide, and it will tell me that at a delta T of 50, that it will give me 1,179 watts. Now we know for the case of a heat pump, we're not going to operate it at a delta T of 50. So in this case of the example, we're going to have a flow temperature of 45 degrees. Our delta T is going to be 22.5 degrees in this case. So what we need to do is we need to look up the conversion factor on the domestic heating design guide. And it tells me here on the image on the right, at 22.5 degrees, the factor I need to multiply the output is 0.35. So when I multiply that factor, 0.35 by 1179, I get an output of 412 watts. So that's an example of how we would assess the output of an existing radiator. Now, the next thing we need to do is we need to look at the room. As I mentioned earlier, we need to do room by room calculations. So I have an example here of a bedroom. So we take the bedroom and we need to take certain information. So we do our sketch, we take our room measurements, we take the information, so what window type and the dimensions of the windows. We need to look at the fabric, so the heat loss for the walls, the floor, and the ceiling. We need to look at the rad size. So in the example previously, I've taken the same radiator for consistency. And then the age of construction can be important as well too, because we might not always know what the U values are. So again, going back to the SEAI room heat loss and radiator sizing guidance, there's a tab there where you can fill in all the details. So I have an example here, and I've taken the bedroom, and in this scenario, it's relatively poorly insulated. So the wall U value is 0.5, the roof U value is 0.4, and the window U value is 3.1. And you can see at the end, that will give us, when we fill in all the different factors, there's other factors there as well, so it'll be self-explanatory as you go to do it. When you fill them in, it will tell us what the total heat loss for the room is. So we need to ensure that our radiator exceeds that heat loss, because obviously it has to provide enough to compensate for the amount of heat that's being lost. In the example where we took the existing radiator, the output of it, and we factored in the fact that it was running at a lower delta T, the output is only 412 watts. So in this case, it wouldn't be sufficient. Whereas in a well-insulated room, and this is quite common because what can happen in parallel with the installation of a heat pump, homeowners may be doing thermal upgrades to their homes or fabric upgrades. So in this case, the walls have been upgraded, the roof has been upgraded, and the windows have been upgraded. And now when we enter in these calculations, we can see it here. The heat loss for the room has been significantly reduced. It's 2/3 of what it originally was, and it's only 404 watts now. So the example that we looked at, the output of the rad, and it was 412 watts. So kind of in summary over those ones there, in the poorly insulated case, the total heat loss for that room was 595 watts. In the well-insulated case, the heat loss was only 404 watts. The original radiator size for non-condensate boiler was 1179 watts, and that was at a delta T of 50. So we need to estimate the existing output. So that's at a delta T of 22, and we can see it's only 412 watts. So the existing radiator can be kept for the well-insulated case, but in the case of poorly insulated or relatively poorly insulated bedroom, a new radiator is required. So what do we do? Well, now we have this information, we can start filling in the heat and design tab. So this one, the well-insulated case, we're putting in with the existing radiator, we put in the room heat loss, and we put in the output off of it. In the poorly insulated case, we've had to put in a new radiator because the existing radiator wasn't sufficient. So we put in the room heat loss, we put in the radiator, we'll ask you to put in the manufacturer details. Look, we've anonymized it for this, we haven't put in the manufacturer details on it. And fill in the data sheet. Now, another example here is, it may be the case, there might have been a smaller rad in that case. We have a flow temperature of 45, delta T of 22, it's 1200 by 450 rad, so it's 400 mils shorter. We look up the heat and design guide, and it will tell us that at a delta T of 50, that a 1200 by 450 single panel convector, we have 888 watts, but we multiply it by a factor for a delta T of 22, and the estimated output is 311 watts. So we'd see from this, in the poorly insulated case, there was almost 600 watts that was required to heat it, and in the well-insulated case, it was 404 watts. So it may be the case that irrespective of whether the insulation is being upgraded, it still may be the case that the radiator is not sufficient enough. So these are just a couple of examples just to kind of show what happens practically when it comes to sizing heat pumps, radiators, and heat loss calculations. Finally, then, this is an example of a completed designer installer sign-off sheet. We've all the radiators listed. We have the top one there in the kitchen. We can see it's underfloor heating. Key points to it, look, the total heat loss is 5,120 watts. The output of the radiator exceeds the heat loss in each room, which is obviously is necessary, plus the output of the heat, the output of the heat pump is greater than the total heat loss as well too. So these things are very important, especially when we have to demonstrate efficiencies and compliance. So when we go to size the heat pump, what do we need to consider? It has to be based on the total heat loss of the home at design conditions. The heat output must be achievable by the heat pump at design conditions. The output must be consistent with the test data for the heat pump. So just make sure you don't mix up models, etc. It must be rated output at design conditions. Some heat pump models will give or will refer to a heat output, but just be careful because this may not be at the same design conditions. So it may not be at a -3 degrees externally. Hot water must also be taken into account when you're calculating your sizing. Then the next thing we need to do is we need to assess the efficiency at design conditions. So FCAI have set out what the minimum space and water heating efficiency should be of the heat pump at design. So both must be met for grant payments to be made. So you can see 300 for space heating and 160 for hot water. The system, please assess the system at design stage. Please do not do an installation. Do your calculations and find out that you cannot demonstrate that it meets the space heating efficiency or the domestic hot water efficiency. And just an update on the DEEP 4 calculation, if the heating demand cannot be met with the heat pump, so if the heat pump is shown as being less than the overall demand of the house, DEEP will assume that another heating system is being used, for example, direct electric, and it will provide the remainder of the load. So that will have a negative effect on the overall efficiency because it will bring down. So this is where, again, I keep saying the same thing, but the importance of correct sizing is essential. Now I bring it to the hot water system. So when we're looking at the hot water system, reheat times need to be considered, and you should agree them with the customer. The domestic hot water heat exchanger specification shall meet the heat pump manufacturer's recommendations. So the heat exchanger, look, most times, or certainly from our inspections, what we would find is that the indoor and outdoor unit, or the cylinder, is from the same manufacturer, and they were both supplied together. But if the heat pump is different, or the cylinder is different than the heat pump, please ensure that that cylinder is capable of meeting the manufacturer's recommendations: length, rate of exchange, size of coil, etc. The minimum insulation of the cylinder must be Part L compliant, for example, 50 millimeters factory insulation. There must be some means to prevent Legionella. And the efficiency must be calculated in accordance with EN 16147 at 55 degrees Celsius. So locating the heat pump, we ask you to follow the manufacturer's instructions and guidance, agree it with the homeowner, take the time and discuss it with them, ask them do they have a preference, and obviously, you know, if there's going to be noise, will there be any nuisance? Was there a better position? You appreciate heat pumps aren't particularly noisy, but in a very quiet setting, it may be audible. It must be in accordance with applicable regulations and planning requirements, and please consider maintenance and in the future. So, you know, accessibility and maintenance. Consider the distance between the indoor and outdoor units, because the volume of refrigerant is defined by the distance between the indoor and outdoor units. In relation to controls, so SEAI, as part of the domestic technical standards and specifications, set out what the minimum level of controls are. You can take them here from the table. I won't go through them one by one. Some really important parts: separation of spacing and heat. Space heating and hot water is essential. Load and weather compensation. And there must be minimum one space heating zone with one room thermostat. It cannot solely rely on load and weather compensation alone. Now, the next thing I'd like to talk about is quality monitoring and inspections. So maybe you're not aware of it. And again, when we distribute this presentation, you can see in the blue section there, that's a hyperlink, and that will bring you to a document called a QADP. On that QADP, the inspector's checklist is listed on it. I would urge everybody to download it and use that checklist as a guide for carrying out your own inspections, for your own snagging when you finish a job. To give an overview of the inspection process, so not every home is inspected. There's a sample of applications are selected for inspection. Mentoring inspections are available. There is a REWORKS process, so where an inspector identifies something on site, we do ask that you return to site and address it. There is an appeals process. Sometimes things happen through no fault of your own. Maybe someone has changed something since your installation, so you can appeal any REWORKS if you feel that they're not through any fault of your own. Just to kind of elaborate slightly on the mentoring inspections. So a mentoring inspection, it's slightly like a kind of a training inspection. It's there, it's offered to contractors, and it's just where an inspector will offer you the opportunity to attend an inspection yourself on one of your own jobs. You can meet one of the inspectors or the quality team. You can see firsthand what the inspector checks. So this will give you an insight as to how the inspector goes through his inspection. You can ask questions in relation to the inspection process and the technical specification. I would urge everyone to ask the inspector as many questions as you have, because it may be a case that there might be other installations that you have done that you may have queries about, not just specifically the inspection that's being done at the time. And the inspector will be happy to give you any information on those. If it's a case that you do other measures, discuss them with the inspector as well too. Perhaps you do heating controls, and the inspector will gladly talk to you about those as well too. If it's a case that the inspector does identify something on site, we do ask that you rectify whatever rework has been identified. But upon notification that they have been rectified, any penalty points that would have been allocated, they are rescinded. So finally then, look, the inspector will give you an overview of his role, and he'll give you his contact details. And please give the inspector a ring. If you have queries when you're doing another installation in the future, get to know the guys, give them a ring, have a relationship. The guys will help you as best they can to give you any sort of guidance on inspections. Now what I want to do is there's a couple of common things that would crop up. There will be a few different things, but there's a couple of common things. There's no point in going through everything that an inspector has found. But what I'd like to do is the more recurring ones. I'd like to talk about those. So when an inspector's out on site, he will have a look at the manual and he will have a look at what the manufacturer's guidelines are. He will check what the siting and the distances and tolerance should be. So just on this example here, we have a copy of the manual. The inspector will open the manual. He'll see that the manufacturer recommends keeping it 300 millimeters away from the wall. That's to allow sufficient airflow through the system. Again, it's a heat exchanger. We want to get a good rate of exchange, and if the air can't flow through it because it's too close to a wall, the system won't work as efficiently. So in this case, the inspector will highlight it, and you will receive notification requesting you to go out and move the unit out in accordance with the manufacturer's recommendations. Another thing is the condensate pipework. So look, you can see from this image on the right, and sometimes when you're doing an installation, things mightn't be as apparent as when maybe a month and a half we may do our inspection, and we can see things kind of being a bit more, there can be a bit more of a nuisance factor that didn't seem as big a deal at the time of installation. You can see clearly here from this image on the right, condensate has just fallen onto the footpath. This concerns me because there's potential for ice, and then with ice, there's a potential for a slip. I'm sure most of you would not like to have applicant homeowners and people slipping due to an installation that you've done. Also, as well, too, there's staining as well, too. You can see the path in the wall there is stained and all from it. What we would ask is, in the case of the condensate, that you pipe it to either a drain, a soakaway, or a gully. Another thing that we would come across is where a unit isn't plumb. So not specifically leveled, we're more looking at the plumbness of the unit. Our concern is bearing damage. So the fan unit's going to be, there's excessive wear, excessive noise. Potentially the warranty may be shortened, and the overall lifespan of the unit could be shortened on it. So again, this is something that we'd ask you to go back to the site to fix. Common reworks, so electrical earthing and bonding. So we can see from this image, there's an earth brought to it, but the pipes aren't cross-bond. What I would like to say is that all metallic surfaces need to be cross-bonded, including the refrigerant pipes. It's stated in IS 101/2020. Just in case you're not aware, that's the newer version of ET 101. Electrically, look, I don't think this image leaves much to the imagination. Those cables, they're just round, they're not clips. They could be put in a tray. They need to be tidy. They're a trip hazard. But secondly, worse still, if someone did trip on them, there's a chance that they could tear or pull them out. There could be a live cable exposed. So this is something an inspector will pull every time they see, if they were to see it on site. Pipe lagging. Quality pipe lagging is important. This is about energy efficiency, and we're trying to distribute the heat from the outdoor unit to the indoor unit. If there's poor pipe lagging, a significant amount of heat is going to be lost before it gets to the useful space. Another thing as well too is we should be looking at the duration of the pipe lagging as well too, taking considerations of protecting it from vermin. Just to give an example, as I mentioned earlier, our inspectors, it's probably a month and a half, from the time an inspection is done. An example here, we have a monoblock unit. The pipe insulation is on it, and in the case of a month, maybe 2 months, you can see how that pipe insulation, that's internal pipe insulation, it's degraded. This system is going to have long working hours, and that's already gone. So we're losing a lot of the energy provided by the machine to the atmosphere. So please take this into consideration. Another point that I'd like to bring to your attention is isolation valves on expansion vessels. Look, Antonella had mentioned it earlier. I'm from a background, I'm a plumber myself. I've never fitted valves on expansion vessels. Expansion vessels are there for the expansion of a system. If a system can't expand, it's going to cause problems with it. What's going to happen? The safety valve is going to blow, at least, where's it going to blow, it's causing the nuisance, it's causing damage to the system, pressure drops, etc. We ask that no manual valves are fitted. There is potential for accidental isolation. I've had it myself in the past where I've seen people turn valves off, forget to turn them back on. They might have a cistern overflowing on the WC or something like that anyway. And they forget to turn it back on. They think everything's working and it's ending up, the system is no expansion, the safety valve is blown off. The pressure relief valve, I suppose that brings me on nicely to the pressure relief valve. And this is a good example of what can happen here. So if the safety valve was closed, if this was on, if this was off the pump and the system was getting topped up constantly, blown off because there's no expansion, the homeowner cannot see that there's an issue on it. And with different components, perhaps aluminium radiators, copper pipes, different metals, steel, etc. in the system, it could be the case that this fresh water is going through the system. What we ask is please fit some means that the homeowner can see that they have an issue. So they can give yourselves a shout and say, look, I think there's a problem, I have a pipe dripping here. In this case, we've asked to fit a ton dish on it. In this case, we asked just to put an elbow on it so it points down to the ground. In the case of this safety valve blown off, we ask just to point it downwards just to reduce any risk if hot water blows off and it may harm someone. I don't think there's much needs to be said about this last image. Look, if there's a problem on it, if this was the house with the 367 on the expansion vessel and the system can't go, it's just going to flood the house. So please make sure that the safety valves are dealt with properly. Pipework, again, an image of an outdoor unit. You've got malleable copper there on the thing. There's no bracketing, there's no clips. Someone stands on it, throws things on top of it. That pipework's going to get damaged. Michael had mentioned earlier, there are CFCs in the refrigerant, and that, if they get exposed, that takes away all the good work in the carbon reductions. Please ensure that the pipework is nice and tidy, just correct pipe insulation, proper brackets, and that the pipework is protected. Another one as well too is room stats. This is something that comes up a fair bit. There's two things in this image. One, the room stat on the wall is too close to the radiator. That radiator or that room stat's going to get a false sense of temperature. So ideally, consider where the room stat's going to be installed so that it gives a good accurate guide to the room temperature. Secondly, there's a TRV on that radiator. So two thermostats will work against each other. If the TRV is set to low and the room stat set to high, the room stat is not going to turn off the rest of the space heating. So every other radiator is there. So we ask, in the case of a room stat, please do not fit a TRV in the same room. Finally, look, I suppose one point as well too is just documentation. I know that Michael has gone through all the necessary documentation and you can have a look at it. Can you please ask that that's left with the homeowner so that they have them at the time of inspection as well too. And the other one there, look, we can just see there must be temperature control for the internal zones of the home. So you can see there's no actuators on this. So it is a requirement that there's internal temperature control in the home or an internal thermostat. Thank you very much. I'm going to pass you on to Antonella.
Thank you, Matt. So a very short conclusion here. So contrary to the saying that heat pumps are only for new builds, there's a lot of business potential for you with homes that have suitable thermal performance, so HLI, for heat pumps. And you can see here some potential figures drawn from the BR database last year. And it's worth noting here that heat pump ready refers only to the building fabric and doesn't relate to heat emitters, so still heat loss calculation and radiator sizing is needed for these homes. But a lot of these homes are on oil and fossil fuel, and we note that conversion of these homes to heat pump systems is a priority in terms of maximizing carbon savings. So I won't go through the specific figures by county here, but we're going to share the presentation and you can look at the numbers in your own time. There's here some two slides more with county figures, one with HLI less or equal to 2 and the other one up to 2.3, HLI up to 2.3. Then finally, some key reminders. Our objectives are to achieve carbon savings and to serve homeowners well. So we're asking you as registered contractors to focus on the quality and efficiency of systems throughout the whole heat pump retrofit project and to look after your customers. So again, on some critical issues that are causing delays in processing grants and have resulted also, some of these have resulted in some grants being declined. So we would like to make sure that these are addressed as a matter of priority. The heat loss calculation must be carried out. These are during the design stage. The heat emitters must be sized correctly, or the sizing of existing radiators must be verified. The heat pump unit must be appropriately sized, and the deep efficiencies must be met. Then on the installation, earthing and bonding must comply with the electrical standards. You need to check that the pressure relief valve is piped and installed correctly, and that all pipework in unheated spaces has the correct lagging. Finally, very important on the missing documents, because there's a lot of delays currently and people getting upset about, been asking things twice. So at handover, make sure that these documents are left with the homeowner. So basically, at the moment they're missing too often. It's the designer installer form with a heating design tab that we showed you in a few slides. The ECODESIGN datasheet, the commissioning certificate, and the RECI cert, or the Safe Electric Completion cert. So now we'll address now some questions that have been put in the Q&A. I'm not sure if there's a few there. So first question was, okay, first of all, I can see, just let me see, I'll present the panel. It's basically myself, Michael, Matt, there's also Marcin, who joined us from the inspections unit, and Orla, who's a building services engineer with more than 20 years industry experience and a lot of expertise on heat pump system design. So first question is about the air change rates. So basically there are some air change rates to be used in the heat loss calculation. So I don't know if, Orla, do you want to take that? There's some values specified in SR 50. I think those should be used.
Yep, so there's values specified in SR 50, and there's a new heat pump SR coming out as well, which will apply to retrofitted buildings. So there's reduced air changes where the building has been retrofitted. That should be used in the calculations.
And the new SR 50-4 also mentioned the air tightness test could be used to determine air infiltration.
Yeah, absolutely. Yeah.
Yes, but let's keep in mind that air infiltration and air changes, basically the design air changes, there's a difference with those. So basically, you can't use the infiltration rate to calculate the heat loss. Is that right?
Yep. So you have to allow for the fresh air demand as well, or the fresh air requirement as well as the infiltration.
Okay. So another question is if the heat pump can be installed with an existing hot water tank. So basically, you need to make sure that the existing hot water tank is suitable for use with a heat pump in terms of the size of the heat exchanger, And also you need to ensure that the manufacturer approves, the use of that cylinder with the heat pump. So I don't know, Orla, do you want to add, or anybody else add anything to that?
Yeah, no, I think you've pretty much covered it. I mean, the main issue with using existing hot water storage tanks is because heat pumps, you need a larger heat exchanger, so you just need to make sure that that it is equivalent to what the manufacturer is recommending. So you need to verify that.
Okay, so we have another question on the sizing of the heat pump unit. I think the heat pump have to be sized to the heat emitter's capacity or to the home heat loss. In this case, I believe it's the home heat loss, in the sense that if the emitter's capacity, in the event that the emitter's capacity is much larger than the home heat loss, what the heat pump unit must cover is the home heat loss. Okay, and basically you need to ensure that the output of the heat pump is at design conditions. Or again, I don't know if anybody wants to add.
Yeah, so in terms of how the efficiency will be adjusted in deep, it'll be based on the heat loss of the home. So as long as it's sized to the heat loss of the home, and accounts for the hot water demand as well, then that's fine.
Okay. And in addition to the previous question on the different hot water tank from the same manufacturer of the outdoor, so basically a different model than, for example, was used in the testing. Do you want to take that?
Yeah,
we can account for that? Yeah.
So what happens within the DEEP software is DEEP has always accounted for the thermal losses associated with a cylinder. And what happens in the calculation is we take away the losses associated with the cylinder as tested. So you could have cylinder A that has been used to test the performance of the heat pump, and the calculation methodology takes away those losses associated with cylinder A, and then in the DEEP analysis you're using cylinder B. So there's no problem using a different cylinder. It's just that you need to know the details of what the unit was tested to, so that you can take those losses away and you're not double counting losses.
Okay, that's great. Another question is on the grant application. So can a grant application be made on insulation measures and also on the heat pump? Yes. So we've designed the heat pump grant in a way that when the technical advisor carries out the technical assessment and, for example, recommends insulation measures, then the grant application can be made for, to support the insulation measures and the heat pump at the same time. So if it's a big project of retrofit, you can include, like the homeowner can include the insulation measures and the heat pump measure within the same application. So you don't have to wait basically until the house is well insulated and then do the heat pump application. And the presentation will be available. I'm not sure what format it will be, but it will be distributed, and also the recording will be distributed in the next few days. Sorry, I'm just reading through the questions. Okay. Orla, this might be one for you. Are concealed wall and ceiling mounted radiant system accounted for as heat emitters in the grant? They'd be treated in a similar way to radiators. So if you can demonstrate that they're meeting the same performance based on the lower flow temperatures, I'd imagine that there's no problem using them in the grant scheme. So basically, you'd need to demonstrate, flow rates, flow temperatures, and how that heat output is generated by those radiant systems. Okay, so in terms of the expansion vessels, we have a remark about valves needed to facilitate this, but I think Matt has covered this in terms of, you know, the valve shouldn't be able to be, shouldn't be operated, so it shouldn't be such that a homeowner can operate it by mistake. Is that correct, Matt, or do you want to?
Yeah, I think that question come up as well. So
yeah.
just to clarify, look, in the case that if you want to fit a valve on the expansion vessel, and 100% appreciate why people do want to fit valves on them, we ask just to fit a lock shield valve, whatever, 1 inch, quarter inch, whatever size the expansion vessel is, that if the isolation valve is lock shield, so it means it needs to be adjusted by a tool and that it can't be done by hand by a homeowner, because you know, what's the balance there? We need to ensure that it can't be accidentally closed.
Great. So in terms of filling out the designer installer form, there's a question on so the installer, designer installer has to fill out these forms. So there's different tabs on the Excel sheet, so they all need to be properly filled out, and then basically, the BR assessor needs them to do the BR assessment, but also the client needs 2 copies, if possible, printed copies, because he needs to keep one for themselves and one must be sent with the DAO form to SCAI. So I hope that this is clear, because it's a very important point in terms of processing the grant applications. Then I think are product fish required also? So if by product fish you mean the data sheets, the ECODESIGN data sheets, yes, they are needed. Obviously, each heat pump must have the energy label, but also the data sheet. I don't know, Orla, you want to add something to it? But basically, we need
Sorry, yeah, the product fish that usually comes with your energy label is basically just kind of a summary of the label. There's a technical under that's under the energy label directive. Then there's a technical data sheet that's required under ECODESIGN, which goes into more detail. And that technical data sheet is required to be available online from all the manufacturers. So that will give you all the detail that you'll require for your BER assessment. So it'll give you the kind of breakdown at part load conditions and the performance of the heat pump. So it's the technical data sheet as per the ECODESIGN requirement is what is required.
Great. And we need the ECODESIGN data sheet also to be given to the homeowner, because we need a copy with the DAO, and that's another important point that I want to make. Okay, then we know, okay, there's a question about using solar in conjunction with a heat pump. So heat pumps tested with single coil cylinders, but not dual coil. I don't know. Do you want to take that?
Yeah, so this is similar to the previous question in that if it's tested with a single coil cylinder, that's fine. And then what happens in the deep analysis is the performance or the losses associated with that single coil is taken away, and then in the actual deep assessment, you'll put it in with the dual coil and allow for the solar. So that's not a problem if it's tested with a single coil.
That's great. And in terms of controlling the system, clearly, if you are integrating solar with heat pump, like you need to make sure that that's done correctly. You know, that there's no losses in terms of, you know, basically temperatures being controlled properly for the correct circuits as well. So the design needs to be done properly, and it needs to be controlled properly to give priority to solar and then meet the remainder with the heat pump. So, or I don't know, do you want to add something to that, or?
Nope.
Okay. I'm just going to say we're 5 minutes over, so okay. why do plumbing contractors get penalty points for electrical works when it's the electrician working? Okay, the contractor is responsible for the whole, for all the works. So basically, you need to check. Like now, you know the main thing. The electricians should be looking after the earthing and bonding. I suppose. Do you want to cover this, Matt, yourself? So, but you are ultimately responsible to check that. I don't know, Matt, if you want to add anything to this.
No, not really. I suppose, look, I sympathise with installers when you have maybe a builder or an electrician working working with you on the job. But the person who makes that grant application is the person who's responsible for the installation, and that's the way that the system works. It's when you sign that grant or DAO, you're saying that I confirm that the installation is done within accordance with all the relevant standards. So that's why. And look, it is a case that you as the installer, you do need to check. I say it. I'd be talking to contractors and all, and they'd say, "Look, the builder said he'd do it. Please don't sign a grant application until you're confident that everything has been installed."
Okay. Another question on existing underfloor heating. That's we realize that's a tricky aspect of this, but basically we need you. If you don't have any information on the heat output of the existing underfloor heating, we need you to use a default value, which is 35 watts per square meter. Or do you want to add anything to that? Because if you don't have any information, basically, you need to be conservative on that.
Yep. Again, the way underfloor heating works is it'll depend on the kind of distance between the coils or the distance between the pipes. So the output can vary. So unless you have the information, you'll have to use the default.
Okay, so I'm just looking. Sorry, there's very, very specific questions. There's a lot of questions coming, and some of them are very specific. So in terms of specific questions, can you please send them to info@betterenergyhomes, or actually info@seai.ie is easier, so that we can log them in the system and then respond to them, because it will be very hard to go into very specific cases.
There's one there on the Deep software. So just to let you know that you can register for the Deep software for free. You don't have to be an assessor, but also there's an Excel version of the Deep software on the SEI website if you want to get access to it and play around in Excel rather than going through the actual software. So the calculation methodology is the same. So if you go onto Deep 4, if you type in Deep 4 into your Google search, SEI Deep 4, you'll get to a page where it'll have an Excel version of the calculator, or you can actually register for to be a user of it rather than a registered user.
Okay. So there's a question on the rated heat output of the heat pump, whether it should be taken from the 35-degree label or 55-degree label. Or like this, obviously, it's depending on the flow temperature that you have on your design flow temperature.
Yeah, so again, it'll be dependent on what your design flow temperature is. So if you are serving a radiator system where it's 45 degrees, under ECODESIGN, you are required to publish 55 degrees unless it's specifically a low temperature heat pump. And when it's a low temperature heat pump, it can't go above 52 degrees under ECODESIGN. So you have to have the 55 degree data. So if you're supplying at 45 degrees and you have the 55 degree data and the 35 degree data, in reality, it's going to be the capacity of it somewhere between those, or it's kind of halfway between those at -3. So it's what the capacity is at -3. Now, the test data that you'll get is at you'll get the various different test points. But if you look at it at 100%, which is at -10 typically, or it can go down to -15, but look at it at the 100% load to see what the kind of typical capacity of that heat pump is. So it'll be somewhere between the 55 and 35, depends on the flow temperature.
Okay. So I think that there's a last question on the HARP database. An update is due to the HARP database. We still don't have a date, but it is due and it will be updated. Then on the underfloor heating, does it have to be documented on the heating design? You need to fill out the watts per square meters and the total heat output of the underfloor heating for the area of the house that covers it, basically. So that's okay. Okay, I think we can wrap up. I hope we answered most of the questions. As I said, we are going to circulate the recording for the webinar, the presentation, and also if there are any other very specific questions, can you please send us an email at info@scai.ie, and we can respond to them. Our help desk and ourselves will respond to those. Okay, so thanks very much to everybody for attending. Thank you to our panel for assisting us, and I think we can close now. Thanks very much. Bye.
Thanks, Antonella. And thanks everyone for taking the time to attend.